Thank you. Yeah, so my name is Conrad. I'm from a company called Siperb, and we are working with WebRTC, and this demonstration today is about specifically the web push. But I just want to take you back a little bit about push notifications in general. It was all in response to the applications, the cell phone providers wanting to extend their battery life, right? So the choice was to suspend applications when they are sent into the background. Makes sense, but it also ends the network connections as well, right? So this meant that VoIP applications could no longer keep their registration with the server because, of course, the network was suspended. And an RFC was developed, RFC 8599, which OpenSIPS adopted in version 3.1. And it makes suggestions about a periodic push notification that means sent. The suggested time is about 120 seconds. And then, of course, this is in combination with a sort of a no delete flag in your location table. All right. What happens is that as part of your registration, additional contact parameters are included, and your location, your push identity is transmitted up to the register. All right, so there's 3 types of push notifications supported and specified in this RFC 8599. Apple Push Notification Service, APNS, the 5S, Cloud Messaging, FCM, that would be Android devices, and then of course Web Push, so we're going to focus on that. And all of this is sort of based on the idea that when an invite is sent to the device, the connection is relevant, or it's recently relevant. The push notifications are sent to the device if they're not online at the time, and the call can be sent down to the device. So more information is available in a blog post on the OpenSIPS blog website. It was an article in 2020 that's specified in this URL there at the bottom. So the thing is, I have a few problems with this RFC. Okay, first of all, sending a push notification to a device every 120 seconds, as per the suggestion, still is going to consume the power. I mean, you're just keeping the application awake in the background though. So the other thing is, sending a push notification now adds network load. Not so much to your device, that's a single push notification, but to your OpenSIPS stack, if you had 100,000 endpoints, would be sending a lot of push notifications. And then, of course, Apple actually have 2 push notification types. The one is a regular push notification for background messages and things like that, and the other one is specifically for VoIP. But since iOS 13, the VoIP push notification can only be used to initiate CallKit. In fact, it specifically says that if you don't present the call answer window that you can slide to answer, it will end your application. All right, so we have success here, but we don't have success with our web push because this whole concept is not compatible with web push. So what happens is that web push notifications are only received by the browser in a special script called a service worker. And this service worker executes in essentially a different domain to your site or your page, which may contain your actual SIP client. And it's considered detached from the DOM, right? So your service worker will not have any user interface, all right? And this is probably not the place where your actual SIP client is going to reside. However, it is possible for web sockets to be active inside a service worker. The problem is that, again, you still don't have any UI or access to the media devices. So really, the web, the service worker is not the place where your SIP client is going to reside. but it is the place that is going to receive the push notifications. All right, so just to summarize here, it seems like the purpose of the RFC 8599 method was to keep a sort of a current connection between the server and the device, or at least current as possible, so that when the invites do arrive, it can be routed to the device. And the approach which I'm going to take you through today, which I believe is a little bit more in line with the communication principles today, is that the device gets sent a push notification to the user of an imminent invite, which gives it time to wake up the app in the background, register, etc., and presents the call answer window to the user. All right, so what are we really talking about here with this web push? Well, there's an example of a web push notification informing you of an incoming call. So what happens is the service worker, that's JavaScript, registers for the push notification, and as I've said, any amount of time can now pass. In fact, the user can close their web browser, they can shut down their computer. And just a note on this, I've given you a demonstration here of an actual laptop PC, but the same infrastructure works on mobile devices. If you have Chrome on your mobile device, or whatever it is, these web push principles still apply. So what happens is the invite is sent through to OpenSIPS. This triggers the event to send the push notification to the contact. All right? The service worker receives this push, the payload's inspected, and the system notification banner is displayed. Now, here's the thing with this. As you can imagine, if everybody was spamming everybody with push notifications on their laptops, it would get out of hand. So of course, the user has to click this banner. All right? You click the banner, and that gives your browser the authority to launch or open a new tab. If the browser is already open, it opens a new tab. If the browser is not open, it actually opens the browser. All right? And then that would make it register and be ready to accept the call. All right, so how do we subscribe to a web push notification? So I know you're at an OpenSIPS conference, but we're going to look at some JavaScript here. All right, so we use the navigator.serviceworker.register. That's a method which takes our JavaScript. So in this SW JavaScript, this is the actual file that's going to contain the push notification event. I haven't got an example of that one, but there's just an event that is raised inside that file. All right, that returns a promise, and a fulfilled promise will of course include service worker registration, but for the moment I'm just logging that out because I really want to give my user the ability to subscribe to push. So I want to be able to say enable push or disable push. So I want to give the user a button. All right, so on that button I'm going to program some events, but one of the events will be of course a permission grant. Okay, so I first need to inquire on a system level, will this guy accept push notifications? So we do that with the API, which is notification.requestPermission. Okay, and that again is obviously a promise because there's now actual user interface which has been displayed to the user. Do you want to accept incoming push notifications or notifications in general? Something which is kind of a little bit confusing. The push notification system actually uses the same notifications as general notifications on browsers. It's sort of like a dual use thing. All right. So if the user clicks yes, then your permission is then granted. And as you can see here, if the permission string is granted, I can now execute my actual subscribe to push function, which I've written here. So it's slightly reduced, but essentially the actual function will take a we're going to look at the navigator.serviceworker, which we initiated earlier on. So that's why we use this .ready. All right, and that essentially just recalls that service worker that we were dealing with earlier on, and I need to then essentially provide it with my subscribe options. So there's two options here, two nodes. This user visible only, it's kind of a weird one, but essentially what it's saying is that, is this notification going to be visible? Well, obvious, right? Yes. There really isn't an option to say false here. So it's kind of just one of these mandatory tick boxes. You have to say yes. All right? And then also in here we have to have an application server key. So what this is now dealing with what's called your VAP ID. That's your public key. So I'm going to go into detail on this a little bit later, but essentially what happens is for push notifications for browsers, you're going to include a payload because you obviously want to have information inside your push notification. But that payload has to be encrypted. It's just mandatory. So now we have to deal with encryption keys, public, private, and essentially this is the public key which you need to put into a certain format, and this is this unit 8 array. So essentially once you build this and you set this application server key, we're going to pass it down to the service worker registration. So I'll take my service worker registration, I then execute push manager dot subscribe, all right, and I give it those options. That returns a promise, and when it's successfully fulfilled, the function that the promise returns a push subscription JSON. This is the example that I've got underneath here. It includes an endpoint, which is this very long, ugly URL. It's a globally unique URL, and it contains the actual endpoint that it will be addressing your instance of your browser anywhere in the world. All right? So that instance of you on the internet is referenceable by this URL. It also includes an expiration time, which at the moment is always null. I think they're going to reserve it for future use or something like that, but at the moment it's just null. And there, of course, are the keys that were provided to you. So this P256DH, that's part of an elliptic curve encryption key system with a random auth as well. And it's all part of the key value pair arrangement which they use to encrypt the message before they send it to you. All right? So that's the formation of the subscription JSON that we need in order to register for push notifications. So I'm going to have a look now again at RFC 88599. And what they specify is the 3 parameters that you include in your register message. And that's PN provider being equal to web push, right, which is just specifies in the documentation like this. It also says that the PN param must be empty. Fair enough. Because the PN PRID must be equal to that endpoint that you just saw. All right, so I literally just copy the endpoint from there and place it in there. All right. Now, Chrome uses the Firebase cloud messaging platforms, and other browsers, Edge, Firefox, they'll all use their own messaging platform to get the messages to you. But they all require the payload to be encrypted with this encryption key system, which is standardized. Okay. So the problem is that if I am not providing OpenSIPS, as you can see, I'm not providing it with any keys, well, how am I going to be able to encrypt the message? All right. So you can see that there's missing information in here. OpenSIPS cannot store enough information for me to send a push notification to myself as a web push notification. All right? And that, of course, means I can't have something like incoming call. Remember, the banner that appears on my PC is going to have to introduce the caller enough that I can make a choice at the time whether I want to answer the call or not. So you can't be blank. All right? Okay, so I'm going back to that little bit of code that I showed you earlier on, and at the service worker .pushmanager.subscribe point, instead of just logging it out, I've chosen to add a fetch command, and the fetch will, in this case, put my subscription JSON onto my API. So I have a URL, api.siperb.com/push/save, and I send essentially that whole subscription JSON up to the server, because I'm now taking responsibility of saving that entire subscription JSON, and I'm not really going to give it all up to OpenSIPS. As we know, OpenSIPS cannot accept all of it. All right, so I just want to look at that endpoint a little bit as well, because essentially the endpoint is this really long, sort of globally unique key, let's call it, but it's not great for storing. Okay, that long URL also had, at one point, it was a long time ago, but there was a special character in it. It was somehow it got OpenSIPS tripped up and it crashed it and things like that. So I really didn't like it. And one thing I wanted to do was reduce it. Okay, so in order to store this subscription JSON, I'm going to use Amazon Web Services. I'm going to use an API gateway, and inside the API gateway, I'm going to point to a Lambda function. And inside the Lambda function, I'm going to have a put method, which we saw earlier on. It's going to store my subscription JSON to a DynamoDB. Okay, that DynamoDB is a key value pair database, and as per the name, I need a key, right, which we're going to develop, and the value is going to be my JSON, my subscription JSON. And then, of course, I'll program in also a post method, which will be kind of the same sort of thing, but this will actually send the push. So as soon as you call post, right, with a key, it will send out the push notification. So that's taken care of actually sending the push and storing the push. All right, but as a key, what I've decided to do rather is MD5 hash the endpoint URL. So it's still now globally unique, it's just in a shorter format. Okay, and I store the key with the value as being the full subscription with the full URL, so I can always return back to that full subscription JSON. All right, and then what that sort of results in here is that my PNPRID is now equal to something like https api.siperb.com/push/send, but now I reference my own MD5 hash, right? Because this is a closed system, I'm going to be sending myself my own information, right? My own keys. So in fact, if you really wanted, you could go PNPRID is equal to your own hash, right? Send it up to OpenSIPS. OpenSIPS will then, at the time of sending a push notification, use this key, but give it to your own API, which in turn translates it into the full subscription JSON. I'm going to have a look at that now. All right, so what we need to do now on the register, so now we're going to prepare ourselves to send OpenSIPS the information we need. We're going to include the PN provider being WebPush. The PN PRID is going to be our own URL or our own hash, a reference for ourselves to our own stored full push subscription. Remember, OpenSIPS doesn't have enough information to send the push notification to ourselves, so we are going to take responsibility for sending this push notification and gathering all the information that we do need. All right? So in order to gather all the information that we do need, I'm going to put together a table inside my MySQL database, which OpenSIPS is already connected to. And it is going to store all the push information here. I'm using a create table push. I include an ID, which will be auto-incremented, the AOR, the actual contact instance, the provider, which will be WebPush in this case, the param, and the PRID. You can see that I've included the param as well because I'm actually going to be storing both APNS and FCM as well, but the idea is that by storing the push notifications in a specific table for ourselves, all the information that came through in the contact, I am essentially taking that responsibility for myself, and I'm not having OpenSIPS save that information. OpenSIPS will read the information, but it will not have enough information, so we will store all the information that we need in the push table and allow the location table to delete out their location, the locations for the contacts. All right? So we're going to have a look at event routes. Essentially the event route that we're looking at is the insert and the update. So event routing, something standard in OpenSIPS, really nice. When a user registers, these events fire off. So have a look at the contact insert event route. Here I pick out essentially the URI, which has got the user information for the contact. I then take out the PN provider, I take out the PN PRID, and I use that to insert a row into the database. Okay, a little bit of lazy development here, I suppose. I know it's not a bad way, but I delete first, and then if the PRID is not empty, well then I add it, right? So it's a self-maintaining database, delete first and then insert. I know it adds a little bit of I/O, but it's kind of simple, all right? So here we can see I'm deleting from the push based on the parameters, and I'm inserting again. I was very glad to see that there's some improvements in the SQL handling, so you see these AVPs will be in the future replaced. All right, and then let's have a look at updates. So of course, updates to the register. If a user chooses to go from push notification to not push notification, deregister for push notification, then of course they will send through an empty PRID. All right, and as you can see in the code here, if the PRID is not empty, then it updates, otherwise it deletes, as per the insert. But essentially, we just have a self-maintaining database that if you're a new registration on the system and you contain push notification data, it's going to store that push notification in the database. And if you choose to deregister, then it'll delete it. But the sort of nice thing about storing the push notification data is that any amount of time can pass. I still have your push notification. If you said, I want push notifications, you can register, shut down, go away, go on holiday, come back, and we'll still have your push notification data. All right? It's got nothing to do with the location table of OpenSIPS. Right, so some other configuration options in OpenSIPS, which are all very much covered in the video on the blog, but I just want to recap. We enable the PN in the register module. We enable push notifications, PN enable. We set up our providers. Of course, again, you can set these, and we want to include this web push one. And then, of course, the match params, which we've discussed at length. So in the user location module, we're not going to use the contact refresh timer because we don't need to. And the other thing that we're going to do is we're going to write through to the SQL, in MySQL database. So what that does is, as you can see here, it's part of the user location module. Essentially, whenever users are added to the location database, they're written immediately to the database, and we're not using the cache system. And I'll show you why that's important in a second. It's a slightly unique sort of architectural approach that I've taken for OpenSIPS. Many of you may be using the same thing, but I needed the location entries to be written immediately to the database without cache, so that I could look them up in another system. And then there's one little change that I need to make to SIP.js. So SIP.js is the SIP stack client that I'm using in my actual client UI in the browser. Okay, it's a well-written SIP library, and it's got a module called user agent, and in the user agent you can pass it some options. One of the options is contact name. Now, as we know, AOR is not the exact instance that you are registered as. It's the bob@somedomain.com, and essentially your contact is that actual instance that you're registered, your laptop or your mobile device or whatever it is that contact instance. So we need predictable contact instances, and that's it. That's the main sort of key and the reason why this works. Because as laptop 1, as that hard code contact, if it goes offline and then comes back online again, it's still contact 1. My AOR may still be Conrad at Siperb, but the instance that I'm referring to here is this very laptop. So when this very laptop, with its unique endpoint that was registered for the subscription, comes back online again, I can tell OpenSIPS to send that device a call, right? Just to be clear on that. Okay, so let's have a look at this sort of, I don't know, unique, well, it's my take on it. Essentially over here on the left-hand side, we've got our SIP clients, our browser phone, WebSocket connections, which go through an elastic load balancer, and this is all AWS stuff. Goes through an elastic load balancer, and the elastic load balancer for that session, right, assigns user A to OpenSIPS server number 2. All right, I'm using load balancing techniques in order to get, say, an invite from OpenSIPS 2 to my logic array. So my logic array stores all the routing and call handling and stuff like that, and my registration array is dead simple. It just contains those contact events, insert and update, all right, which store my push notification. But no further registration action happens after this point. This registration array is the end of my registration, and I use routing logic to get the calls out through onto other services or to other users. So if I did have to complete a call from user A to user B, essentially they would both connect via WebSockets through my elastic load balancer for the entire sessions onto, say, OpenSIPS server 2. It would then go onto my logic array. My logic array would then fire the push notifications, see where user B did register. So it goes through the elastic load balancer onto OpenSIPS, what's that, number 4, and then this logic array will then be able to see the user register, be able to send that call to that user and down to the device. And then, of course, media will flow from user A to user B. All right. So now we have everything set up. We have our push notification registered. We have our logic in place. But now we need to look at the way the gateway array is configured. So now OpenSIPS has got a new set of objectives, and we are going to handle the push notification sending and setup and all that kind of stuff. And in order to do that, we have to go through the following steps. So on receiving an invite, OpenSIPS needs to perform the following. We check in the location table, so the regular location table, for matches on our AOR, right? That's standard. And we build an array of online contacts, right? We then check the push table, which we created, all right? It's a unique table. And we also check it for also the same thing, AOR's matching, and build essentially what's called our push contacts, right? So the online contacts are the people that are actually, or the instances that are actually registered right now. The push contacts are the people that, as you saw by those two events, have told us that we want to receive push notifications, all right? So if these two lists are 0, well, now we can send the call to voicemail or reject the call or whatever you want to do. You're not available, Okay? But if I have online contacts and I have those same contacts in my push array, what it means is that even though I've subscribed for push, I'm online. You don't have to send me a push, right? So we reduce those users from my array, from my push array. Okay? So we're left with an array of online contacts and push contacts. So let's have a look at the online contacts. Okay? If that list is 0, okay, so no people online, I'm only going to be sending push notifications. We obviously need to prep OpenSIPS to be able to handle this situation. So we create a new transaction with this t_neutron, and we send back a t-reply 180 ringing. Well, are we ringing? So I put in here push, all right? Essentially, we didn't have any online users, but we're going to try, right? We're going to send through the push notification, so there's a very good chance it's going to be ringing. So I've said here, yeah, I'm ringing, all right? I even think WhatsApp does this. It sends through a call, it tells you it's ringing, but really it's hunting for the guy, all right? So then I'm going to have a look and say, okay, if my online array, my online contacts is greater than 0, if there are some people that are online, I'm going to use the very standard OpenSIPS way of sending a call to a user. I set URI if there is only 1, okay? And then if there's more than 1 in that array, I set URI for the first one and use append branch for the second ones. I mean, this is pretty standard call forking sort of stuff. All right. So let's have a look at the push array. If the push array now is greater than 1, okay, we're going to tell OpenSIPS that it must expect new branches to come in later. All right, and we do this with this t_wait_for_new_, could you have renamed that? Anyway, so we use this method to prep OpenSIPS that there will be new branches being appended to this transaction at a later stage. Then we need to do one other thing. Now, the truth is that we're going to be doing a lot of sort of waiting around inside OpenSIPS, and as you know, we don't like to hold up OpenSIPS. All of this has to be done asynchronously, and there is a kind of like a very interesting thing that needs to happen where OpenSIPS needs to continue to process, be available, but it cannot be held up, so you've got to keep using things like events in order to get this right. Okay, so we're going to use something called a contact event again, which we saw, contact insert we saw from the other slide, but this is in our gateway array, and our gateway array never gets any contacts, it never gets any registrations. So we are free to use these events for ourselves, all right? And I'm going to essentially tell it that I want you to notify me when this event gets raised, and I want you to go to the route called users_registered, okay? So that means that someone has registered, okay? Then I'm going to go to my push array, and I'm going to build my JSON for my own API. And this is where I can do my own customizations, right? I can put my own caller ID in.
3 minutes.
Okay. I can put my own caller ID in, I can put all my own information inside this JSON, and I can send it to my own API. I do that with the REST post method, and I include my URL, my body, the type, and the return types, and all that kind of stuff are populated into arrays over there. And I send it with a function called launch, all right? And when launch executes, it lands up in a place called push result, but push result is irrelevant. We don't really care whether the push has got sent or not, and we can use our own API to handle that. Then finally we press the big old send button, which is your T-relay, but I add another parameter inside there, which is this 0x02, which just tells it don't panic if there's no actual calls to be sent to it at the time. So right now, some devices will be registering and users will be coming online. So I need to check my database for these new people coming online. So I use sleep and I wrap it up in something called async with a route called check database. So essentially, in 1 second, go to this route. And in that route, I simply have the t inject branches as a method, which then injects the branch into the transaction. Pretty straightforward. So this is that new branch that we talk about. And inside my check database route, this is where we actually are going to check our database. Using a standard query, we're just going to query our push table, our location table for new locations. So we obviously filter out all the people that are online or all those kind of things. These are only people that were recently pushed to. So I then raise the event, which then injects the branches, and I create it in a loop called a check database. So here at the bottom, I loop back to myself. I say check database again, which essentially goes around in a loop, round in a loop, round in a loop, without holding up OpenSIPS. These are all asynchronous actions. Okay, so I wanted to give myself enough time to show you the video. It's worth it. Watch the video. It's a minute long, okay?
You got a minute.
Okay, so I've got two users, users 200 and user 100. User 200 is going to call 100. It's first going to be online, so it'll be the online array. It's going to reject the call, and then it's going to answer the call just to show you that all the signaling is working. What you need to look out for here on the top right, you will see the push notifications. There'll be a notification, which is its internal notification, but you'll see when I shut down the application, this is a PWA, so it is a web browser, but it's being formatted as a PWA. All right? And when user 100 is shut down completely, I still send the push notification, and I still dial the user, and it's able to go through. Okay, let's have a look. So there I'm making a call. The user's online, but I can reject the call. And then I'm going to make another call to the same user, and just to show you all the functionality is working. I answer the call this time, and now media is flowing directly from user A to user B. Alright? Usual sort of stuff, nothing magical. But now I'm going to shut down user 100. So that's like closing a browser tab, restarting the computer, whatever you like. It's actually offline, you can see that. But I call it anyway. So look out for the push notification on the side. You can see now, incoming call, that's a system notification. I have to tap that and click that. That launched my PWA and gave it time to register. And as soon as it's registered, it's available to answer the call. All right. And that's me. Thank you very much. My name is Conrad. There's some more information on our website, siperb.com. You can email me, you can LinkedIn me, Twitter me, GitHub me, whatever you like. Thank you.